Vignesh, and I am the course instructor for a subject called Mechanics of Solids. And today we will talk about two things. One is the introduction to stress and strain, and the type of forces that a body can experience anywhere. Okay, so let's get started. So, firstly, an important thing is the mechanics of solids. Okay, so mechanics of solids is a very good subject, very important subject to learn, because this will be a prerequisite for something called mechanics of materials or even strength of materials, whichever course you're going to take. So mechanics of materials surely is dependent on MOS. The other thing which is dependent upon this is SA, structural analysis, and then you have RC, steel, even to a certain extent. So these are very important subjects that you will learn in the coming courses and coming semesters, and a base is formed for all these subjects because this is the subject that you will really learn. Okay, so always study MOS really well. Apart from this, if you have fluid mechanics, please do study all that. Okay, so let's get started. I'll just start this off from the screen so that it's easier for us to go to something called stress. Okay, now what do we associate stress with? Stress is always something which everyone tries to ignore, tries to combat and everything. But in MOS, stress is really a resistance to external forces. What do I mean by that? What do I mean by stress is the resistance to external loads? Imagine you being seated in a chair or somewhere. Okay, when you sit down, the chair doesn't break or get itself repaired. That's because the chair is exerting an equal and opposite force to your weight. Now that equal and opposite force is called stress, and that's why your chair doesn't break, or wherever that you're sitting right now does not break. So that stress is the internal, that's very important, internal resistance to the external force. In this case, when you sit, you are the external force, and the internal resistance is the chair's ability to resist loads. So if that makes sense, let me go to the next one. But always make sure that stress is really important. The definition itself is kind of like a very favorite question for HR or even the technical personnel when you go to an interview. So stress is nothing but the internal resistance to the external forces. So when you sit down, the chair doesn't break because of something called stress, right? So that's the first one. And stress is denoted by sigma. Okay, that's that. And a very important question again is what is if someone asks in the interview, what is stress? And everyone tries to go to this thing called load by area. Okay, the external load divided by the area which resists the load. So that's actually stress and its definition. But always try to talk about this particular sentence to anyone who asks you about stress. Okay, stress is the resistance to external forces. Now come to something called strain. Again, all these terms, stress and strain, are related to your body. Sometimes someone will ask you what is happening in your leg. Someone will tell there's a strain or sprain in the particular part of the body. Now, yeah, that's correct. The same thing happens for an object. When you load something, when you load an object with a particular force, now what happens is, how do I say this in reality? Take a 5-star bar. Okay, let me just say that this length is the original length, and you're trying to apply a little type of force like this. You're just pulling it apart like this, and when you start to pull that 5-star bar a little bit more. It tries to reduce in its how do I say, in its internal dimension, like this, and it sort of expands when you keep on loading it. Okay, so this difference right now, this difference that you see over here, okay, this is del 1. Let us just take it as L1. That means the difference in length when you try to pull it, as you see over here. And at one point of time, the Munch or 5-star, it just kind of breaks. Okay, it just expands really well and it breaks somewhere in the middle. Okay, so this difference in the length, let us just take it as del L final. Okay, this with respect to the initial length, you have an increased length of delta or del L final. Now how do I say this? So strain is nothing but the difference in the length with respect to the original length. So if I say del L final is the difference in the length and the original length is L, this ratio that you see over here is called strain. Okay, and it's again you denote it by this strain, just the change in the length by original length. It can be extended to any other part also. You can also say that change in dimension divided by the original dimension. So if you take a ratio between these two, that comes to strain. Okay, so yeah, I forgot to mention about the units over here. So strain does not have any unit. This is like when I am a lecturer or assistant professor for 10 years right now. Most of the time students make mistakes in their units, and particularly somewhere over here, strain, they say it's in Newton, it's in Newton per mm squared and all that, but it actually doesn't have any unit. Now why am I saying it doesn't have unit? Now if you take strain, okay, I'm just going to use that denotation, delta L final by original length. Now if you take this, delta L is nothing but a dimension. Okay, it's just a distance. So if I measure it in millimeters, and if I have the length in millimeters, then these two get cancelled and you end up having no unit. This is really important. Strain does not have any unit. I forgot to mention about the stress again. Load will most probably be in newtons, because we are going to use newtons for the entire course. So let's just take loads in newtons, and area, if I take it in mm squared, because we're taking everything in mm, because it's all very small things which happen in mechanics of materials. So this will be ending up in a unit called Newton per mm squared. Okay, so always remember these two terms are going to be majorly important, critical for you to know. So stress is the internal resistance to your external loads. Think of it like you sitting on a chair. The chair doesn't break because it is actually resisting your load. And think of strain as the 5-star bar that you're trying to expand, and at one point of time it's gonna break, but the change in length is something which you can measure, and when you divide it with respect to your length, that will give you strain. So these two are done with. Now let's go to some